Good morning, students. This is the sixth session of your chapter, that is quadrilaterals. In the previous session, that means in the fifth session, we already learned some properties of rectangle and rhombus. So today we are going to discuss the properties of square, kite, trapezium and isosceles trapezium. Okay. So first, square. As you all know that a square is a polygon. A square is a polygon bounded by 4 line segments, right? A square is a quadrilateral in which all 4 sides are equal. So what are the main properties of square? Here A, B, C and D. A, B, C, D is a square. Square is a quadrilateral in which all 4 sides are equal. Right? So, write one by one properties. First property of the square. All the 4 sides are equal. So what are the 4 sides here? The length of AB is equal to BC, that BC is equal to CD, CD is equal to DA. Next, second one. The opposite sides are parallel. Opposite sides are parallel. It means a square is also one of the parallelogram. Okay. So what are the 2 pair of opposite sides here? AB is parallel to CD. This is the first pair. Next one, BC is parallel to AD. So these are the 2 pair of opposite sides which are exactly parallel to each other. Next, third one. Adjacent sides are equal. Here, adjacent sides, the length of the adjacent sides are equal. So, in the particular quadrilateral, as we already studied in the previous classes, in a quadrilateral, we can write 4 pair of adjacent sides. Okay, so all the adjacent sides in the square are equal. So AB is equal to BC. This is the first pair. Next one, BC is equal to CD. Next, CD is equal to AD. That AD is equal to AB. So these are the 4 pair of adjacent sides of the square. Okay. Next, fourth property of the square. Each angle of the square is always 90 degree. It means each angle is measuring 90 degree. So all the angles are right angle. All the angles of the square are right angles. Angle A is equal to angle B equal to angle C is equal to angle D. The 4 angles, each angle measuring 90 degree. So in the square, each angle is 90 degree. Next, fifth one. We can draw the 2 diagonals in any quadrilateral. Here also AC and BD are the 2 diagonals. the length of these diagonals, the length of diagonals are equal. The length of the diagonals are equal. So the diagonal AC is equal to BD. AC is equal to BD. These two are the diagonals. The length of these two diagonals are equal. Next, sixth property. Here two diagonals are there, AC and BD. These two diagonals intersect at one particular point and the two diagonals are bisect each other. Diagonals bisect each other. Diagonals bisect each other. Means here the point of intersection is considered as a O. Then each diagonal divided into two equal parts. So OA is equal to OC. Each diagonal divided into two equal parts. OA is equal to OC and OB is equal to OD. These are the bisected parts of the each diagonal. Next one, seventh, the diagonals are intersect perpendicularly. Diagonals are intersect perpendicularly. Perpendicular, it means when two diagonals are meet at one point, at point of intersection it forms 90-degree angle. So angle AOB is equal to 90 degree or angle BOC is equal to 90 degree or remaining two angles is also 90 degree. So here angle AOB equal to angle BOC, which is equal to angle COD equal to the last angle DOD. So each angle measures 90 degree. Next, eighth property. When two diagonals intersect, each diagonal, if I take only one diagonal here, AC is a diagonal, it divides the square into two congruent triangles, right? Each diagonal divides the square into two congruent triangles, whereas if two diagonals intersect each other, it forms four congruent triangles. This property we already learnt in the properties of rhombus, right? When two diagonals of the rhombus are intersect, it forms four congruent triangles. So in the square is also the same property, that is when two diagonals intersect each other, it forms four congruent triangles. Diagonals form four congruent triangles. So congruent means the two geometrical shape which are same in size and shape, right? So what are the four triangles here? Triangle AOB, which is congruent to the triangle BOC. That second triangle is congruent to the third triangle COD, which is congruent to the last triangle DOA. All these four triangles are congruent to each other. This property can be proved similarly, as we already discussed in the previous class. By using same procedure we can prove this statement. Okay, next one, ninth property of the square. Here you are observing the diagonals. The diagonals divides or the diagonals bisect the angle that which passes through the vertices. For example, here AC is a diagonal, no? This diagonal passes through the point A and it divides or it bisects the angle A into two equal parts. It means the angle OAD, if I take diagonal bisects each angle. For example, if I take AC as a diagonal, that point A or AC diagonal bisects the angle A as two bisected parts are angle OAB, one more angle OAD. So angle OAB and angle OAD. By adding these two angles, we get a one complete angle, that is A, right? So these all are the properties of the squares. What are the properties? First one, all four sides are equal. Second one, opposite sides are parallel to each other. Third one, adjacent sides are equal. Next, fourth one, all the angles are measuring 90 degree. Next, fifth one, the length of the diagonals are equal. Sixth property, the diagonals bisect each other. Seventh one, diagonals intersect perpendicularly. Next, eighth one, diagonals forms four congruent triangles. When two diagonals intersect, it forms four congruent triangles. And last one, diagonals bisect each other, the diagonals bisect the angle that which it is passes through. Okay, so these are the properties of the square. Next one, take the next quadrilateral, that is trapezium. So trapezium means what? Trapezium is also a quadrilateral in which one pair of opposite sides are parallel. Okay. So the next quadrilateral is trapezium. Here ABCD is a trapezium. You can easily identify it in the given figure. What are the two sides which are exactly parallel to each other? Here AB, the side AB is parallel to CD or DB. Okay. So how you can define the trapezium? Trapezium is a quadrilateral. In which one pair of opposite sides, one pair of the opposite sides are parallel only, but they are not equal. One pair of opposite sides are parallel. So let me discuss the properties of this trapezium. First property, as we all know that the opposite side, one pair of opposite sides are parallel. So first property is one pair of opposite sides are parallel. One pair of opposite sides are parallel. What are the one pairs? AB, the side AB which is parallel to the side DC. So this is the one pair. Next, what about these two sides? These are the non-parallel sides, and the remaining two sides, if two sides are exactly parallel to each other, means the remaining two sides of the trapezium are non-parallels. So remaining two sides AB, AD is non-parallel to BC, right? Next, second property, if two lines are parallel, means the angles formed between the parallel lines, is always equal to supplementary. It means the sum of two angles formed between the parallel lines is equal to 180 degree. So here AB and DC are the two parallel lines, and these two parallel lines forms two angles. The sum of these two adjacent angles, is equal to 180 degree. So angle A plus angle D, which is equal to 180 degree. This is the first pair. second one angle B plus angle C, which is equal to 180 degree. These two are the angles formed between the two parallel lines. Angles between parallel lines. Angles formed between the parallel lines. Next, third one. Here AC is the first diagonal and DB is the second diagonal. The length of the diagonals in trapezium, the length of the diagonals are different. Diagonals are measuring different. The length of the two diagonals are different. It means that AC, which is not equal to the length of the AC, which is not equal to the second diagonal BD. Next, so these are the three properties. Next one, again, if the length of the diagonals are not equal means the diagonals will not be bisect each other. That is the fourth property. So these are the main properties of trapezium. Again, we are classifying one more trapezium. We already discussed in the previous class, that is isosceles trapezium. Isosceles trapezium. So isosceles trapezium means what? A quadrilateral. Isosceles trapezium is also one type of the quadrilateral in which one pair of opposite sides are parallel and non-parallel sides, remaining two sides are non-parallel sides. No, the non-parallel sides are having exactly equal length. For example, here I will take one isosceles trapezium. This is the isosceles trapezium A, B, C and D, in which the length AB is, the side AB is parallel to, the side AB is parallel to DC, and the non-parallel sides AD and BC are measuring equal length. So take the first property of isosceles trapezium. One pair of opposite sides are parallel. One pair of opposite sides are parallel. So parallel sides AB is parallel to CD or DC. Next, second one. What is that second property? The non-parallel sides are equal. Non-parallel sides are equal. Non-parallel sides means if we are extending the two lines, they will meet at one particular point, right? So these two are the non-parallel sides. So non-parallel sides are having equal length. So non-parallel sides are AD is equal to BC. Second property of the isosceles trapezium. Next one, third property. Here also the angles formed between the two parallel lines are supplementary. So angle A plus angle D, which is equal to 180 degree. Again angle B plus angle C, which is also equal to 180 degree. So these two are the angles formed between the parallel lines. Next, fourth property, as well discussed in the trapezium, the length of the diagonals are different in trapezium, but in isosceles trapezium the diagonals are measuring equal length. So the length of the diagonals are equal. Diagonals are equal. It means the AC, the length of AC, diagonal AC, which is equal to the another diagonal BD. But in normal trapezium, the length of the diagonals are different from one another. But in isosceles, the two diagonals are measuring equal length. So these are all the properties of trapezium and isosceles trapezium. Next one more quadrilateral, that is kite. Kite is also one of the quadrilateral. That we will discuss the properties of the kite. Next quadrilateral is kite. A, B, C, D. Here A, B, C, D is a kite, right? So how you can define the kite? A kite is a quadrilateral. A kite is a quadrilateral in which adjacent sides are having equal length. Either sides of the adjacent sides, either you can take top two adjacent sides or bottom two adjacent sides. The adjacent sides are equal. So first property. What is that first property? Adjacent sides. Adjacent sides are equal. The top two adjacents are exactly equal and bottom two adjacent sides are exactly equal, but we cannot consider these two as equal. For example, here AB is equal to AD. The length of these two sides are equal, but it is not equal to the CD and CB. Okay, adjacent sides are equal. So AD is equal to AB and one more pair is BC, which is equal to CD. Second one, the length of the diagonals are different. When we draw the two diagonals in the kite, the length of these two diagonals are different from each other. So diagonals are not equal. So AC, the diagonal AC, which is not equal to the second diagonal BD. Next, third property. Here AC and BD are the two diagonals, no? So when these two diagonals are intersect, the diagonals are intersect perpendicularly. It means the two diagonals, when two diagonals intersect each other, it forms 90 degree at the point of intersection. Again, the angle AOB, the angle AOB is equal to 90 degree, or angle AOD is equal to 90 degree, and remaining two angles is also 90 degree. So diagonals intersect at perpendicularly. So the AC is perpendicular to BD. Next one, fourth property. When the two diagonals, here in this given diagram, AC is the diagonal, no? So this diagonal bisects the first diagonal into two equal parts. Means the diagonal BD divides into two equal parts, that is OD is equal to OB. OD is equal to OB. And the diagonal passes through the first diagonal, it bisects the diagonal into two equal parts. So this is the fourth property of kite. Next, fifth one. The opposite angles here, these two angles are measuring equal. Angle B, which is equal to angle B, is always equal to angle D. Angle B is equal to angle D. So these are the some basic properties of kite. So in this session we learnt some properties of square, trapezium, isosceles trapezium, kite. Okay, in the next session we will discuss some basic problems depends on these properties. Okay, be happy, have a nice day, thank you.